Good morning, folks. We're going to give it a minute, as we usually do, for the room to fill up. And
Hello, Drummond.
good morning, Carly. And I will get the agenda ready here. Right. Share screen there. That'll do it. There we go. Yeah, as hopefully folks are worth taking a look at the agenda. We have because we have special guests today visiting us from Hong Kong. They are going to go first on the agenda right after our announcements and have their we'll have our special presentation on the OpenAC project. So just making let's give it I usually give it till 8:03 to get going. Um, and we'll give it just a minute here. Um, and welcome to all the members of the um, ZKID team that are here to join us today. We're looking forward to that presentation very much. All right, I'm going to give it another 30 seconds and we'll get going. Room is filling up nicely. Also, let's see. Yeah, I got a note from Martina. My actually both of my co-chairs are missing today. Nikki Hickman is at a conference in London, and unfortunately, Martina's down with it sounds like it might be the flu. So she gets better. All right, let's go ahead and get going. Welcome everyone to the April 8th meeting of the Decentralized Trust Graph Working Group. We are a joint working group of Trust ORP and the Decentralized Identity Foundation. Both of us being at the Linux Foundation, we always operate under our antitrust policy notice that I have right here. I'm going to do a quick check. This does not apply to our guests here from the privacy stewards of Ethereum, but if there are any other new members that want to do an introduction, you're welcome to do that. I encourage you to do it either in the chat or we have a DTG. I'm going to put it in the. That's it there. That's the our bio page document. You're welcome to add a bio too. All right. Quickly, just so we're on the same page, we're again going to start out. We'll do quick announcements, but then the early part of our meeting, because they are visiting from Hong Kong and it's late for them, will be the presentation from the ZKID team. And then we'll quickly cover the new task forces we're proposing, credentials task force report, and preparation for our all-member meeting that is a week from today, Trust OIP all-member meeting. So that's our agenda for today. Very quickly, any announcements besides our standard reminder that Internet Identity Workshop, Agentic Identity Workshop are coming up shortly. So any other announcements that folks want to share?
I had one, Drummond.
Go ahead, Brendan.
I think many of you know that Alberto and I work for the Applied Social Media Lab at Harvard University, and we have a digital identity symposium coming up next week It was decided that it should be in person only. So I'm sorry about that for the many of you who are not in the area. But for those of you who are, I'm going to just copy into the Zoom chat the invitation, and there is a RSVP link at the bottom. And we'd love to have any of you join us who would be interested in doing so. So that's in the Cambridge area in Boston. It looks like it's a little too big for me to post directly into the chat, but I will get it into the document here. But it's on. What I'll do is I'll take a minute after I'm done speaking here to just chop it into some smaller chunks so you can see the text and then the RSVP link. So
Perfect.
yeah,
Yes. And
there.
I can put more info into the notes
Oh, and I
too as
should,
well.
of course, note that Drummond is one of the speakers, so that's also very much worth mentioning.
Super glad to be going and seeing you're going to be the SML wallet that you've shown before is going to be featured. So I'm really looking forward to that.
Yes, that's also been rebranded as Keyring. Again, that was something that was just decided, but it's the same thing. Don't worry. ASML Wallet is the same thing as Keyring now. Okay.
Ah, okay. Keyring is going to be the new name for it. All right, fantastic. Excellent. Any other announcements before we go to the Ethereum Foundation team? Oh, good. You're going to go ahead and put that in there. All right. If there's not, let's go ahead now and introduce the team. I'm assuming you're going to want to present, so I will stop sharing. And and I don't know, Zoe, do you want to make the introductions, or how do you want to proceed here?
Yeah, I'm happy to do the introductions. Thanks for having the team here today. Can you all see my screen?
Yes, indeed. That looks great. And one question, is this a presentation you can share with us? Not necessarily right now, but just until we can put in the notes or not. It's just I'm just asking.
Yes, definitely. We'll share it with everyone afterwards, and there are links and QR codes for external links to other resources that might be of interest to you.
Fantastic. Thank you.
Cool. So with me today, I have Vivian, who is the technical team lead of ZKID team. I have Vikash Rishi, who is the lead developer on the project, and Nicole, who is a PM for some of our integration projects in Taiwan. And just a quick overview of our agenda today. We'll introduce PSC as our team. We'll talk about a little bit about OpenAC, the construction, do some brief comparisons to other ZKP schemes, including BBS Plus and Longfellow. And then we'll present some benchmarks for the performance of our work, and then introduce some like features that we've been thinking about. And then we would also love to open up the floor for questions or any comments you guys have for us. So yeah, to begin with, what is PSC? PSC is an R&D lab for applied zero-knowledge proofs. We've been around for the last 7 years under different names. We used to be called Applied ZK, and then Privacy and Scaling Exploration shortly after that, but we recently rebranded to Privacy Stewards of Ethereum. We're a team of researchers, cryptographers, and developers, and some of our previous work includes development of ZK libraries, software developer toolkits for mobile proving, Semaphore, which is an anonymous signaling protocol, as well as client-side proving, benchmarking, and FHE and MPC research. So all the work we do is open source, it's a public good, and we're a nonprofit fully funded by the Ethereum Foundation. So some existing deployments of ZKs that include some of PSC's work in the past include some of these examples I've listed here. So it is like a fairly widely deployed technology, including $47 billion secured in L2 solutions that use zero-knowledge proofs. And Semaphore, which is a protocol that was created by a PSC, is actually in production now with 37.7 million users with WorldCoin and the foundation there. There is also a lot of identity deployments, including ZK Passport, which you might have heard of, ZK Login, Provider ID, and also anonymous voting apps deployed in production, both in Georgia and Russia. So yeah, beyond identity data, we want to make like an effort to say that this ZKs are useful for any type of signed data, and can be used for many applications in data provenance as well as business use cases. So a little bit on OpenAC, the main motivation for it was the cryptographers' feedback on the EUDI for the use of SDJOTs and salted hashes being not unlinkable. So we started this work, I think, early last year. And the main reason for that was for that cryptographer's feedback and preventing verifier issuer tracking, as well as verifier tracking. So for the last year, we've been working on the OpenAC implementation. In a short line, it's an open and lightweight anonymous credential system that takes a SDJOT and creates a proof on top of it. It's compatible with existing systems, so existing DID and VC formats, and it provides unlinkability to credentials. Our first iteration of it provided age verification, and it also has best-in-class proving time, and we're currently working on generalized predicates. We published an OpenAC white paper, which I'll link towards the end of the presentation, but it describes a generic ZKID construction. And the main thing to take away is that it's modular in its components, so the underlying proof system can be switched out for the future, particularly with like the context of like post-quantum upgrades. And one thing that I think stands out for our solution compared to many others is we mapped it directly to the EUDI high-level requirements. We've also done a lot of standardization efforts with both the W3C working groups. We did a draft of a PCS draft for ZKPs at the IETF. We've also worked with Linux Foundation, and at the moment we are one of 3 profiles selected for the ETSI document that we're writing a profile for OpenAC. We've also done a bunch of revocation research, which Vivian will talk about shortly. And then I'm going to stop sharing my screen so that Vivian can share hers and continue.
Yep. Can you all see my screen?
Yeah, we can see it. Yeah, looks good.
Good. I'm gonna talk now a bit more about OpenAC. And OpenAC uses standard cryptography. For example, Spartan 2 is field agnostic, but OpenAC standardizes on T256, and also P256 is NIST standardized, and also is standardized ECDSA P256. Here, I'm gonna show a quick demo, and I'm gonna pause the video so that you can all understand a bit more. And right now, we have a demo, which is an application for a phone and mobile application, and it looks like this. This is like the demo to show the flow. And you open the application, and this is what it looks like. And to start, it will unzip some data. That's why you see here some data. The app size is almost 60 megabytes. And then in this phase, it will start running some setup for the keys for the CK part that it's gonna use after. So you can close the app, and it is running in the background. So no credential yet, just the app after it is installed. It's running this pre-processing for the setup to use CK after. And then now the system is ready to receive a credential, and right now it's receiving a credential. This is what it looks like when you receive a credential in your phone. You will run these following processes. You will run the prepare process. I'm gonna explain that both processes at the end, prepare and show, but I'm gonna show you what it looks like now. And the prepare process is running. And what is doing that? This is just preparing so that is more efficient to generate the proofs after when the verifier wants to ask for something. And what happened here after the preprocessing is finished, then the verifier can start asking about the credential and you can start to generate the proofs. And we see that the proof was generated quickly because we did some preprocessing before, and that's why it's faster to compute the proof after. So this is the demo, and the demo is using CK Pro to port the Rust code to mobile with Flutter, and the user experience is improved in the setup and prepare phase because as you saw at the beginning, you can just close the app and everything is running under the hood. So you only have to open the app to actually generate the proof when the verifier is asking for something. Here is the complete flow, and I'm gonna explain what is happening so that you can understand. So there are three components, the issuer, the holder, and the verifier. And this first part is related to device binding, and I'm gonna explain a bit more during the presentation. This part here is for device binding, and also there is device binding here too. Device binding is the property to make sure that the holder contains the credential in the same device that the issuer used to issue the credential. So this is important for the verifier to ask to the right holder with the right device and the right credential. And this then in the how is device binding performed, I'm going to explain a bit more later, but it's just the issuer will use the holder public key to bound it to the credential and then send the credential to the holder. At this point, the holder will contain the credential and the issuer use the holder public key for the credential. And now when the holder contains the credential, they can start in the device, you saw the first process of prepare. That's what is running under the hood in the device. So it's doing some pre-processing, and the verifier can start to request for example, age verification or any other property about from this credential. And when the verifier requests from something from the credential, then the show part is gonna start to happen, and the holder will run in the device the show step, the show phase, and after this is done, there will be a CK proof, a proof if they are, in this case, older than 18 or not, and we'll send the proof to the verifier. So the verifier then will just verify the proof and check if they are older than 18 or not, without knowing anything else. The verifier won't know anything about the credential. They will only know that the holder is older than 18 in this case, and just that, and that the proof is successfully verified or not. So this is the original generic CK-SNAR architecture. So for some context, the issuer will contain the message contain the attributes, the name, address, and other attributes, and there's also a signature. So then the holder will use this signature to validate it. And here is where the CK part happens, and where the holder will take the credential attributes and use the verifier request to create the CK proof, and then we'll output the CK proof and the public outputs and the outputs, so that the reliant party, the verifier in this case, will be able to verify the proof and use this output to decide what they want to do. For example, in the case of age verification, they will verify the proof, and with the output will be if it's true or not that they are older than 18, and then they will decide what they want to do with that information. And as I mentioned before, one of the features is device binding, and this is a relationship between the issuer and holder to make sure that that the holder contains their credential in their device, and then also the reliant party will use the session ID is a way to make sure that the holder here is check that the holder contain the credential that was issued to their device, and they are creating the CK proof for this specific request from the verifier at that specific time. So the main two phases in OpenAC are prepare and show. In prepare, this is the phase that is running under the hood when the user, in this case the holder, gets the credential. And what is happening here is parsing the document, like parsing the credential, doing some hashing and signature verification. That can always happen offline. The user doesn't need to be online, and that happens in the background. And then there is the show phase. The show phase is the one that happens at presentation time, which is the moment that the holder is generating the CK proof because the verifier requested something from the credential. And this is the part where the selective disclosure is going to happen, and the CKP for the verifier will be generated. There is a reblind process that I'm going to mention because you're going to see benchmark, but what this process is doing is to making sure that proofs are unlinkable. So to keep privacy and things like that. So I'm going to mention, I'm mentioning this here so that because you are going to see benchmark, but it's, the main two phases that you saw in the are prepare and show, that the ones that you will see more. But under the hood, there is always happening reblind to make sure that to keep privacy. The OpenAC design is modular because it can support any type of document, any signed data. Right now it supports SDJWT, but it can also support like MDL and support any other type of data because the parsing layer is independent. So you just have to implement that part, and the other project, like the other logic is still the same. I'm gonna mention some things related to similar approaches. And for example, there is the BBS and BBS Plus, Longfellow, Crescent, and also OpenAC. And regarding issuer modification, for example, some solutions will require, like BBS and BBS Plus, will require issuer modification, and then OpenAC doesn't require that. And this means that the issuer will need to change their signing algorithm or something like that. And also the offline phase, so to optimize presentation time, there are these two phases, and there are some solutions that won't do these two phases, and then they will do everything every time they want to prove something. And regarding the setup, like some solutions require trusted setup, and OpenAC doesn't require that, and which is better for privacy in general. It's better to not require trusted setup. And features like device binding, some solutions will integrate it and some others won't. And as I mentioned before, BBS Plus and BBS Sharp in this case require both changes to the issuer signing algorithm. And for example, in Longfellow, they combine both, and then there is no this offline phase. And also Longfellow is implemented with low-level CK circuit code, so it's more difficult for developers to use it and to develop with this. And it lacks of support of generalized predicates right now. And for OpenAC, these are some benchmarks. The proving time is 99 milliseconds, for blind in 30 milliseconds, and verification time is 30 milliseconds. This is proving that you are older than 18. And this is when the verifier is asking if you're older than 18. These are the benchmarks that they will get if you run that statement. Regarding revocation, so revocation is a very important part of an identity system, and it's the process that allows an issuer to invalidate a previously issued credential so that the verifiers can detect that this credential is no longer valid. So right now, after we did a lot of research on different solutions and deep research on medical tree-based approaches, here in this QR code, you can see the full blog post, and we also, with the Decentralized Identity Foundation, we are also collaborating on this report focused on different solutions for revocation, and you can check it here in this QR code. And so far, for popularity, for performance, and real world solutions, so it looks like no membership proof in a list of revoked credentials, using Merkle trees is a very good solution for real world applications, real world implementation, and that's what we are gonna integrate soon in OpenAC. Regarding generalized predicate, this is an important feature for the identity solutions because sometimes you want to ask more things about a credential. You don't want to ask about one attribute. Sometimes you want to ask more. And this is the idea of generalized predicates, to ask anything you want about a credential, and also combine different things and create logical expressions and make it easier for verifiers to be able to request information while keeping privacy. And some examples of predicates are age verification, like you're older than 18. For example, they can also request French proofs, like I want to know if the annual income in euros from that person is between 30K and 60K, or also membership if the residency country is part of a list, of non-membership if the residency country is not part of a list, and some other more complex expressions, like if you have been working for more than 2 years and your annual income in euros is between 50K and 100K, or your account balance in euros is more than 10K, things like that. So you will be able to create more complex expressions. And in this QR code and in this link, you can check the full design and more details about the implementation, because we implemented it recently. And the flow is just taking the expression and turn it into a more simple sequence so that it's CK friendly, and then everything will be checked and it will only return true or false. So the verifier will only know if it's true or false, the full statement. They will know if this was true, this part was false. They will only know if the full expression is true or false. So regarding developer considerations for OpenAC, the level to understanding and to use it is minimal for developers, so it's very developer friendly, and the time for integration is less than 2 weeks, and it's mobile friendly because the demo was also created with OpenAC. It's mobile friendly, compatible with existing document types and libraries, and the developer experience is easier now with the SDKs, because it's going to talk about that in the presentation. And also that OpenAC is using Sericom, which is the most popular and used CKDSL right now. I'm going to stop sharing so that Vikash can continue.
Yeah.
Yeah, let me go. Okay, yeah.
I think I was not able to share the screen because like someone is already sharing the screen. Maybe
Yeah.
Yeah, so whoever's sharing, if they can stop sharing, which occasionally there's a Zoom bug that you can't stop sharing. Hopefully that's not the case.
Yes, I didn't see how to stop. Yeah, it didn't
You
let me
said stop
stop
sharing,
sharing.
and it's still sharing.
Yes,
Ooh.
let me try to share it again and see if I it can stop sharing.
See if it unsticks.
This
Yes.
might not. We've had this problem before. Sometimes you have to leave the whole meeting in order to stop the sharing.
Okay.
Yeah.
Maybe Vivian, you can just
Remember,
keep going, and Vikash can
if,
present off your screen.
Okay, yeah, I can
or
just do that. Let me
Yeah,
let me go.
if you can present um um those slides, that's fine.
Yep, yep. I think that's way better. So yeah, since we talked about like developer like experience and all, so OpenAC uses this language called Circom, which is like widely popular in all of the ZK ecosystem, which is also very granular and very intuitive at like developers can easily understand it. So we made this simple SDK, which is a wrapper of the entire OpenAC flow, where you could just download the package and try to perform all of the OpenAC flows. Something like you could do presentation flows, you could do verification flows. And one of the things which we try to like abstract away is like develop abstract away is like the entire the cryptography parts of it. So the we try to abstract most of the cryptography hard ZK parts of it and try to make it as intuitive as possible. And the entire SDK runs in inside like your backend node servers, or like the even in the web browsers as well. So you could install with npm I OpenAC SDK. So for the following slide, so one of the research ideas we are pursuing was like making the existing OpenAC post quantum, meaning the existing approaches and our OpenAC heavily relies on elliptic curve assumptions, meaning any good quantum computer can break this assumption in the near future. So we would like to start this research on like making the components of the entire OpenAC post quantum. And there are like EUDI ecosystem is also moving towards post quantum readiness. There are like discussions going on. How do we implement and what are the characteristics of the uh, approaches as well. So in the following to that, like NIST also finalized like post quantum standard algorithms as well. So yeah, so in the following slide, so even though we are pursuing post quantum, we don't want to trade off with the existing properties of OpenAC, which are like transparent setups and post quantum re-randomizable proofs. Meaning, if we just put the entire stack into post quantum, we might lose like few of the properties which are very essential to any ID ecosystem or like EUDI. So the ideal goal for the entire research for making OpenAC post quantum that could have all of these properties. The first one would be transparent setup, meaning no trusted ceremony or no third party randomness, trusted assumption. And obviously proofs will be post quantum, and re-randomizable proofs, meaning people can be compute efficient, they can pre-compute the proofs, and also which could have like unlinkable presentations as well. And the third one would be issuer compatibility, and we don't want to change existing issuer algorithms or like any data formats, and we want to keep the stack as modular as possible, and then we want to switch into entire post quantum. So the third one be cheaper reblinding, meaning you could do efficient pre-computation of the proofs instead of computing the entire proof. And the last two would be the additive homomorphism in commitments, meaning you could efficiently link between commitments and have the unlinkable property. And we wanted to achieve 128-bit post quantum security. So these are our targets. We are pursuing this research direction in the following months. Yeah.
Yeah, I think so. You can share your screen.
Oh, sure.
No?
Can you reshare your screen?
Okay, yeah, I can.
Thanks. So yeah, just to summarize the main points that OpenAC is offering is that it's secure by construction, no trusted setup is required, which is one of the basic requirements from the EUDI. It's modular and generic in construction, so it can support any arbitrary assigned data. And I see in the questions, yeah, somebody also asked if it supports JSON-LD. At the moment, we don't have support for it, but it is definitely something we can add. It's optimized for multi-VC linking, compatible with the EDI high-level requirements, provides device binding support. As Vivian also mentioned, there's expressiveness of predicates. It's also under MIT license and open source. So we are still working on it. For the next 3 to 6 months, we're going to add support for multi-VC linking, so the ability to create a proof out of 2 separate verifiable credentials and predicates on top of that. We're exploring post-quantum solutions. We're adding more features like revocation. And then we also saw from the first person's projects, you guys are using ED 25519. So we're providing support for that for the VRC signatures. We'll also do MDoc support. There's also a large initiative right now to do a revision to DID Ether. And we're currently writing the Etsy profile for their standardization process. And we're also exploring different methods for public registries and data infrastructure on Ethereum. Next slide. So we've provided a bunch of links. This OpenAC Studio that Nicole put together is a no-code, easy to demonstration of like what kind of features you can put together and add together from OpenAC. So if you're interested, you can have a look at that. We also have the ePrint paper, as well as the full implementation on GitHub, open sourced. So we're really curious to hear from you if you're working on identity use case and how we can iterate OpenAC to work for you. If you see any additional requirements, feel free to reach out to our team. Or if you have challenges or blockers for adoption, we'd love to hear about those too, and just generally be helpful. I see there's a few questions in the chat, so thanks for answering some of these, Nicole. Do we still have time? If we do, we can maybe answer a few. Otherwise,
we intentionally wanted to give you the balance of the agenda is pretty flexible, so we want to give you're getting a lot of it was I'm just going to say a very comprehensive presentation. The reason you're getting a bunch of questions is this is a key piece of DTG architecture, and so we really appreciate it. I definitely want to take as much time for questions as folks want to take, and the team can handle. I know it's getting late for you in Hong Kong, but it would be great if I think you've already. I'm going to look. I think folks were queuing their questions. I was trying to do the same thing. You've already covered the one about JSON LD support. We are starting out with our credential formats, as you've seen, defined in W3C VC 2.0. But you've already said that's something that you're working on. So that's excellent. Steve, you had a question about if using predicates is return true if all true or false if any false, and it looks like, was that already answered?
You can expand if you can expand more on that, but the idea is that it will evaluate any logical expression. So it will contain any logical operator and or not, and it will just return the final result if the full expression evaluates to true or false. It won't return all the small expressions, just the full expression if everything evaluates to true or false.
Right, classic. Okay. I'm realizing there are also hands up, so I'm gonna let's go those and then we'll go back to the chat. So Christian, go ahead.
I'm usually the guy who shows up asking about interoperability on these calls. I have a did method. They have a did method. Everybody's got did methods. Are you looking at being flexible with the provenance of the verifiable credentials? Like, can you take a credential that's been recorded on outside of Ethereum, for example, and it has all the information to validate it. And could you incorporate in your process so that a credential and a method that does not support zero knowledge today could still issue a credential, and through your wallets and tools, you could read that and prove it to with zero knowledge to a third party? Question.
Yeah, we're actually completely agnostic to what chain. It's like it's not even on chain at the moment. All OpenAC does is that it takes a verifiable credential. At the moment, it's an SDJOT, but it can support any VC, and it will create a proof over whatever predicate you set, and it will present it as a verifiable presentation. So yeah, completely agnostic to whatever did method or whatever chain or whatever use case you have for it.
Thank you.
That's fantastic. Marcus, go ahead.
Yes, thank you for the presentation. Very interesting. I have a question about key types. I think you mentioned you did this with P256 keys, but my understanding is Ethereum natively uses SecP256K1 keys. So how exactly does OpenAC work with Ethereum? And second question, you said you're adapting this for ED25519 keys. I'm curious how difficult is that, or how easy is it to adapt the OpenAC approach to other key types like ED25519?
Yeah, I would take this question. So for the context, like Ethereum uses like say K1 curve, let's call it K1, and we are using P256 curve. And the general procedure is like whenever the signing algorithm, whenever issuer has like a different set of signing algorithms, and we are like completely independent from all of the you could theoretically use any signing algorithms, and we could able to prove these statements inside ZK. So these statements are like they're not related to Ethereum's different curve, but the construction we are using is like completely independent. Meaning, let's say if there is a new signing algorithm and which we wanted to use, you could use that in the current OpenAC stack. So
Marcus, did that answer your question?
I think so. It also answers my second question about ED25519, right?
yeah,
You said that the stack is independent of the signing algorithm, so
yeah.
you could use any one. Okay, I understand. Thank you.
It's very interesting. Okay, Brendan, go ahead.
No, this is great, and I see all the thought that's gone into trying to make this broadly usable, and I appreciate that. Just a question. I'm not a ZK expert, but I'm aware that there is a trade-off space of, performance, covering different use cases, etc. Could you describe, where you've kind of located yourself in the trade-off space, and if there's certain things that are less available or not as ideal in order to achieve all these wonderful aims that you're tackling here?
Yeah, I think the main considerations we had was the selection of the underlying proof system that OpenAC uses at the moment. And the three dimensions would be proof size, proof time, and then also RAM consumption. And since we're optimizing for mobile devices, that was a large consideration. So in the initial selection of Spartan for the proof system, that's the main consideration we had. And if you're interested in the comparison of the work that we did for, I think we benchmarked something like 20 CKVMs over SHA-256, and they're also available here. So yeah, we took that research work and then selected the appropriate proof system for OpenAC.
Wonderful, thank you.
Yeah, I know this is. I mean, I've been learning about this area for quite a while, and there's still all kinds of questions that I have about it, and that this is as comprehensive a presentation that I've seen. So I will ask one additional question just because of talking with other folks that are very interested in the space. It's particularly interesting. You are aiming and wanting to meet the EUDI requirements. There's one of our participants, the Ceros Foundation. Have you been talking with the folks at Ceros, Leif Johansson and his team about OpenAC?
I don't think so. Is it Johannes, the same Johannes that wrote some of the Etsy documents, or is it different Johannes?
No, so it's Leif Johansson is the executive director of Ceros, and he's but one of the folks he's working with. If you talk to Peter Altman with the Swedish government team.
Oh yeah, Cirrus Foundation we haven't talked to, but Peter we've been talking to for the Etsy profiling. Yes.
Yes. Okay. Good. Good. That was what I know that Peter is sort of at the center of that discussion. If you satisfy him, you will satisfy the Ceros team. So, good. Good. I just wanted to. That would be a huge win there. That'd be fantastic. Okay. Reza, go ahead.
My question in the comments was, for complex data types, do you support similarity scores? So let's say, for instance, an address is a complex data type, and someone asserts they live at this address, but you have on record the same address, but some of the fields might be slightly different. How do you resolve that? Do you require in the proof to construct some Boolean expression, or do you support the vector representation of data so you can have similarity comparisons?
I don't think we support that yet, but that's interesting to understand as a use case if you're seeing that repetitively come up.
Yeah. Okay, so that was that, and that leads me on to I saw in one of your slides you said fully homomorphic encryption. Can you expand upon that?
So the intention was like there are like the work we do specifically, which is like zero knowledge proofs. The another type of work which we do is like FHE, which is also known as fully homomorphic encryption. So which lets you do computation on encrypted data, meaning let's say I have A and I have B, and encrypt the form of A into some ciphertext and B into some ciphertext, and you could theoretically do all these sorts of computations like addition, multiplication, all of these things with homomorphic encryption. I think in one of the slides which we mentioned was additive homomorphism, meaning let's say I have some proof and I have like some commitments within the proof, meaning I am above 18 and things like this. Let's say I could, instead of like sharing the entire thing, we could like theoretically do all of the additive homomorphism things within the proof itself. So I think that should answer your question.
Right, and you have algorithms that are fully homomorphic?
Yes, we do have some algorithms, but which we didn't integrate it within OpenAC right now.
Okay. Are they published yet? We're tracking this whole space and see what algorithms are open and are available.
Yeah, I think there are like widely open source repos such as Sunscreen. Zama has this like FHE libraries, which is like concrete ML. So that lets you do like all of this encrypted computations right now.
Okay.
Yeah.
Thank you.
Excellent. As you can see, we got a lot of folks, a lot of interest. I'm checking here. Do we have any other hands up? No, and I'm just checking. Do we get everything from the chat? I did ask about user experience, and Zoe, thank you for that excellent answer. You can tell the depth of your experience in this area. It's great to see a whole team working on this. I guarantee we will be back to you with a lot more. We are planning on starting a ZKP task force, and this was a wonderful kickoff for doing that. I'm going to do one last call for any other questions for the OpenAC team. We do have one more. Jorge, go ahead.
Yeah, if I can ask a question, in the slides, one of the bullet points mentioned that OpenAC doesn't require trust handoff or trust negotiation. Can, can you elaborate on that? Like, does that mean that there's no trust registry or data exchange to issue the credential? I guess I'm wondering if you can elaborate on what you mean by that.
Yes, like trusted setup, you mean?
Yes, that was
Yeah.
it. Yes.
Yes, so trusted setup is a process that some proving system will require. Proving system is what is used to create the CK proof. And some proving system will require a trusted setup. And what is a trusted setup? A trusted setup is a process to secure the system. So for example, for Gross 16, you need to run a process in so that many people will add randomness, like will add values. And as long as one person is honest in this process, the full process is secure and the proving system is secure. So some proving system will require this process and others won't. So we always want to use proving system that don't require this process because it requires you need to run this process asking people to add randomness and then do this. And some processes, some proving system will require this. For example, Gross 16 will require this for every circuit you have, and other will require just one universal like Plonk, but you still need to do this process. So in our case, like for OpenAC, you don't need to run this process. People don't need to add a randomness to secure the system. The system is secure by default, so you don't need to run any process to secure the system.
Yeah, so just to elaborate a little bit more, it's a design constraint of the underlying proof system that is selected for the ZKP scheme. So yeah, it's just important, I guess, to understand that the scheme that is selected must not require trusted setup. Yeah. And OpenAC does not require it.
Understood. Thank you.
Yes. Going back to my days at Evernham, it was a real trade-off about needing trusted setup. And so you've gone way down the road from where we were with the initial, what's currently a non-creds, and that's a huge advance. Excellent. Well, so much for trying to get you back to bed early. I suspected there would be a whole bunch of really good calls. I cannot thank you enough for taking the time, both to analyze what where we're going, what we needed, and what we will need, and to share your expertise with us. It's really deeply appreciated. As I said, we will absolutely be back with you. And a shout out and thank you to Otto for introducing you to us. Yeah, again, thanks very much. We will. We'll be back at you soon. But in the meantime, if you have any questions, anything comes up, just let me know, and we'll. And thank you for these links. I will add them, Zoe, to the notes here. I've been trying to. It's been difficult because there's so many things to cover here. I hope we didn't, in the end up interfering with your sleep too much.
No problem. I'm just going to drop one more link for the presentation for anybody who wants.
Oh, perfect. That is just what we needed. And there are folks I know that were not able to attend the call today who were telling me, "Oh, please make sure to get a link." Of course, they can't listen to the recording as well. I'm certain I will say our next agenda item is simply that we're planning. We have 5 current task forces, each of which has their own dedicated repo, so we can have discussions, issues as they're working on any specifications. And what we're going to be doing is our proposals for 2 more of the ZKP task force, and then 1 on user experience, because that is critical to everything we're doing here. So we definitely would love to have you be part of that ZKP task force. One of the reasons for the repos and the emphasis on GitHub is asynchronous collaboration, because we can't do all of this on real-time calls. So I will definitely be back in touch, Zoe, with you and your team about as we get that stood up, so we can continue to collaborate there if that's something that would be of interest to your team.
Yeah, definitely. I'm just gonna drop my Signal handle in case anybody wants to get in touch with the team. So feel free to reach out.
That is the shortest Signal handle I've ever seen. It's excellent. Fantastic. Thank you very much. And thank you to your whole team. That was one of the best presentations on ZKP as a deep topic that I've ever seen. So really, really deeply appreciated. All right, I'm going to quickly, we just have 4 minutes left. So yeah, you're getting lots of thumbs up and hearts, and well-deserved all the way around. And again, I hope you're able to sleep well tonight. Okay, in our last couple minutes, again, this is just, we wanted to give everyone a heads up. We're prepared now to, we talked last week about the ZKP task force and why we wanted to, I think you just saw the illustration of how badly and timely it is to get that started. We do have the Ceros team, the Berkeley team, Hart Montgomery, the CTO at LF Decentralized Trust, all very interested in getting that going. So we'll get that underway, get the repos set up for that one, and also the charter. And again, the other one that it now keeps coming up is UX. And even though we may not have folks ready to pile into that, I want to get the repo set up and have that there. So as discussions start to come up in the UX area, we have a discussion area. Just so for the OpenAC team, again, we're emphasizing we do have Discord channels that are used, both for Trust European. We can set up Discord channels for any of the task forces, but we're emphasizing having discussions on the repos dedicated to those task forces. Plus, we have a general one for general discussions. So we'll go ahead and get those set up. Lastly, very briefly, we are still slowly making progress, thanks to Jeff Turk on the template specification. Still not done yet, but finally in this next week it should get done, so we can start getting that first credentials spec out. And the very last thing is, I just want to remind everyone, Trust OP has now a semi-annual all members meeting, and it will be a week from today in the 2 o'clock time slots Pacific, 2100 UTC. And we will be reporting out, several, Martina and I, on behalf of the Decentralized Trust Graph Working Group. All the working groups will be just sharing highlights of their work, and with a special emphasis on what is going on in the marketplace. How are we starting to have an impact, and where's this going? So we're going to do this just twice a year, right before the annual Internet Identity Workshop, Agentic Internet Workshop meetings, and folks will be talking about what sessions they plan to have at those conferences, so you can help get prepared. And I will tell the I'm actually going to add a slide to what I was planning to present, to highlight this presentation by the OpenAC team. It was that good, and I want folks to know we are actively on that key piece. And I will point out to you that it was part of our charter, since it was emphasized so well in the original personhood credentials paper in August 2024. And I'm just really glad that you're doing the work you are, because a lot of folks said that was going to be the hardest part of actually making personhood credentials possible for the internet. And you're helping prove that we can do that. And with that, we're done. Next week, we will have Martina. Hopefully she's feeling better. We'll go back into the interaction architecture diagram work. I have some fascinating discussions with her that we will also be putting on the GitHub repos. And then I'll actually be doing that from the airports on the way to Cambridge for the Harvard ASML event. So we'll look forward to that. And with that, we're at time. So again, a big thank you to the OpenAC team. And I hope you sleep well.
Thank you. Thank you very much for having us.
Our pleasure. Really is truly awesome. Yeah, that's it. I love those. Yeah, you can get the full set of those. All right, very good. Well, talk to everyone soon. Take care. Bye-bye.